In my last video, I left off with this picture of a breadboard, starting to think about potential layout of the ICs and other components for the 640 by 480 video card. Maybe just as a reminder, this is what I'm currently working with for the address space. I've updated this just slightly. I've shrunk the video window in my address space down to 64K. And that is this A0000 to the end of the A's as far as the range. I have a 64K chunk available above that, the B's that I'm not doing anything with at this point, and then I have C on up for my ROM, and then RAM is everything up to the video addressing. And I mentioned in a previous video that I'm using the I/O address space so that I can do I/O reads and writes separate from that memory mapped types of reads and writes, to get to a register, or that's the plan, is to get to a register in the video card to configure a few things. And some of the things that I'm going to be able to configure, hopefully, is to select the active frame. So right now I am targeting 2 frames in my video card. So that might look something like this. And each of those frames technically has 1 megabyte of physical memory. But at least for now, the design, I'm going to start out with the video card will only use 1/2 megabyte from each of those. So frame 0, the VGA out is leveraging the first 1/2 megabyte of frame 0 or the first 1/2 megabyte of frame 1. But from the 286, it's just going to see these as a 64K window into those, and then I'll use this register to flip between which frame 0 or frame 1, and then within that frame, which of the 16 different 64K segments is the 286 having access to. So if you want to think about it, I've got 4 bits that's going to help me select which segment, and then 1 more bit that's the frame. So I really have 5 bits that help me address into that 2 megabytes worth of VRAM on the video card. And in the future, I think that'll give me some flexibility. I can either use those upper 1/2 megs for just regular memory for the 286, or I can use it for other things on the VGA design. And in time, I can change those around as far as how I use them, but that's where I'm starting. Now the goal here is that I'm going to have my 286 be able to access a frame, and let's just say that it accesses the upper frame, frame 0, and simultaneously the VGA output can be leveraging frame 1 and trying to keep the buses separate for these so that there is no contention to deal with whatsoever. And this is maybe a clarification from my last video. Again, Liquid Nyquist had followed up just maybe with some clarifying comments there, and I went back and had made some changes just to make sure that I was supporting this properly from the hardware side. And then with my registers, or the register on the video card, I can then switch it and have the 286 access the other frame while the VGA output uses frame 0 in this case. And I can switch back and forth. So I can be outputting something to the screen and then preparing the alternate frame for the next video output, and then try to synchronize that to my VSync signal when I make the switch, so I can cleanly switch between the two. So that is the plan. Now there's, I want to say, quite a few moving parts to this, or at least for me there's enough moving parts that I'm not going to try to implement this all at once. I'm going piece at a time. And the first thing I'm going to focus on really is just this. Can I get my 286 system to access frame 0 of the VRAM, and will I be able to make that part work? And so if I go to my schematic, this is not intended to be readable in this video, but this is just a high level of my schematic, which is on my blog. I've updated it slightly since I last posted on the blog, but you should be able to get the latest there, and it should be pretty close to this. But if I look at this, in the upper left I have an ISA slot. So really this is just the edge connector on my VGA card, where I'm going to pull in address data and other important signals like memory read-write and I/O read-write signals as an example. And then I have these multiplexers that the 286 will basically send in its addresses over here into these multiplexers, as will at some point my VGA output will send in the appropriate addresses, and then the multiplexers just let me switch back and forth. What they're controlling access to really is the video RAM, so to only let the 286 or the VGA output access to the same memory chips. So it's one or the other, they're mutually exclusive. And then I have some transceivers down here that really roll this memory back to my 286. So kind of the loop here that I've got is the ISA card. I'll be able to send in the addresses of the RAM I want to access, and then the actual data access of that RAM happens through these transceivers back to my 286. So that is bidirectional. I can write to the memory, I can read from the memory, and I'm going to set the memory addresses through the multiplexers. And then later I need to then say, okay, I want to switch from this set of RAM to the other set of RAM. So then I would have to come down here and make sure that this set of multiplexers is allowing the proper addresses in for my 286 so that I can write to this. These multiplexers then would let the appropriate data flow to this set of RAM. So two sets of transceivers, sorry. The idea though is that I'm going to have one or the other that my 286 will connect to at a time, and then on the output to my VGA I'll be able to say which of these two sets of memory are actually used to draw the video output, and I'll be toggling back and forth like I showed in those previous graphics. Well, what I want to be able to do is test maybe this much of it. You know, can I get in here and get signals from my ISA slot through the multiplexers into the first frame of memory, and then be able to access that data, write to it, read from it through the transceivers. And to do that, I'm going to have to make sure I have some starter decode logic in here so that these multiplexers know when to let those signals in versus not, and when these transceivers are going to let signals through, and in which direction are those signals going. So the testing that I have set up so far is going to let me test that much of it, and what I am not trying to test or take into account yet is all the rest of this. And so I have all of this addressing for my video output. I have the actual video output circuitry. I have my second frame and its multiplexers and transceivers. And I have this register over here. None of that am I worried about yet. I'm just worried about, can I get in and test the things that are marked with these green boxes. So I've gone through and I've connected everything up to try to do that testing. And this is what it looks like. So on the left is my 286 system. I've got plenty of previous videos where I talk through that. Showing a couple of things. I got the 286 here with its little card up here for power and clock and things like that. Off to the right now, I'm doing my VGA circuit on this set of breadboards, and I'm using another one of these cards up here purely just for power distribution. You can see that I'm just jumping power from this card over to this card's input, and then using that to then connect into the rails on the breadboards. This card really isn't doing much, it's just power distribution is all it is. But if I look at this, some things to point out is I have an ISA slot. So I've got two ISA slots on my 286 system. Well, this ISA slot to the far right is what I want to get into the breadboard. So I've done that just with some adapters that I have. Here's an adapter this was probably from my 65816 system. I used ISA slots and didn't necessarily follow the ISA standard for that system, but I did have this nice little card that lets me break out from an ISA slot to a ribbon or pin out. And then when I was building my custom 16-bit processor, I had made up these little PCBs that let me take a ribbon to it and then tap into a breadboard. And so between those two, I have this card here. I'm grabbing the appropriate signals that I care about and bringing those over to these three little adapters that are plugged into my breadboard. And so basically I'm going address, the high end of my address down to the low of my address, and then some other control signals, and then all my data signals from data 15 down to data 0. Just making it accessible for the breadboard is all that I'm doing here. Then I have my multiplexers down here, and I've connected the first set of multiplexers for the frame 0 memory. So here is my static RAM, the multiplexers. So I'm going to take addresses from up here, I run them down the side and into all the appropriate inputs on these multiplexers. The outputs of those multiplexers then go into the addressing of my RAM chips. Now at some point I've got this PSOC that's going to generate my VGA addressing, and that will come up into these unused pins on all of these multiplexers. But that's more for the output, and I'm not to that point yet. And then all of that pretty much gets duplicated for this set of VRAM for frame 1. So frame 0, frame 1. Now the multiplexers come in. I use the transceivers for the data, and here's my transceivers. So the data from these static RAMs are going through these transceivers back to the data connection that goes to the ISA bus over to the rest of my 286 system. So if you kind of want to flow through that, I'm going from all of this 286 through this mess of wires into these connectors, and then flowing my addresses down, my data, and it's all coming together at these static RAMs. So that is just plain old static RAMs, a pair of them that I'm treating as my video memory or my video RAM. Transceivers, like I mentioned, and then I'm doing some, well, my goal will be to do quite a bit of decode logic inside of this PSOC right here. And the logic that I'm using so far is really, really simple, and it's just this. So really, I could have bypassed the PSOC. It's not doing anything at this point other than passing some signals through. But I set it up this way because I know I have other logic to put into this as I tie in my next frame and as I start to tie in the video output. So I wanted to have my wiring be correct to the PSOC so that as I build out this logic, I'm not having to rewire, I'm just changing things inside the PSOC. But this is what I have here for now for the logic. For example, helping me control my static RAMs, which of the two static RAMs, the left one or the right one, the high or the low, are enabled. And that's done with these two signals, A0 and BHE. Anything that ends with a B is just an active low type of signal. This tool doesn't seem to let me put a hash symbol, a pound sign at the end of these. It doesn't allow that in the naming, doesn't allow exclamation points. So I'm just using the B for bar. And I might be missing something in the tool, but that's how I'm doing it today. Then I come over to my system, and up here, this clock that's driving my system, previously I was running this at 36 megahertz, which brought 18 megahertz into my system, which ran the processor at 9 megahertz. With all of this mess over here, I knew there was no way I was going to be able to run that type of speed. But I do have it dropped in a quarter of that. So, and I did actually, let me start with, I took out the 36 and put a 32 megahertz oscillator in here. And if I was going to run directly off of that, that speed just falls apart when I try to go through all this wiring mess. So I did drop that down, and at this point I am running 4 megahertz into this board, which means the processor internally is running at 2. So the peripheral clock and all of that is running at 4 megahertz. So that's really what I'm having to support through this wiring mess, is a 4 megahertz type of signal. And that is working. It does fail if I go to 8, but it does work at 4, and I'm plenty happy with that, considering I'm just using these pin headers into an ISA slot into wide open wires that I'm sure are picking up all kinds of noise as they do that. And then I updated my ROMs on my 286 to really do a couple of changes I made. I took out a lot of the postcode and initialization stuff just to speed up testing. And I'm really only doing 2 tests during my power on self-test. And the first is I'm testing all of the system RAM. So I have system RAM in the 286. There's a meg physical, but I'm using 640K. So I test that 640K by backing up a location, writing a new value, reading the value, making sure it matches, and then restoring the original value. And I cycle through all of the memory with that approach. For my initial testing over here, I just wanted to make sure I could get to these chips and see if I could write and read. And I'm only testing the first 64K. And primary reason is up here is my register. I don't have any of that register hooked up yet. And the logic to get to the second segment, third segment, fourth segment, etc., of the 16 segments available on this memory, I don't have that logic in yet. So I just said, let's tie those signals to 0 to low, and I'm only accessing the first 64K. But then I put in a test to actually test that 64K. And this might not be super readable on the video, but hopefully at 4K you can read it okay. What I'm essentially doing is just coming in, I wrote a procedure called post VRAM that gets called from my general post routine. And in this then I say let's go to 1000 and I decrement down. So I start at really the top. I start at the AFFFE and I work my way down word by word, and I write an alternate value to it, and that alternate value is a dB, and then I read it back, I compare it, so here's the write, here's the pulling it back, here is the comparison, and then I just check, if it failed or not. If it didn't fail, go to the next memory location, keep testing. If it fails, jump down to the fail and write out to this little screen that it failed. So that's what that code is doing, and then if it works, this is what I should see on my little OLED post screen. So it should say RAM test pass and VRAM test pass, and this is the actual results that I took a picture of. This was passing just fine. And so I did go in and make sure that I could cause a failure. I came over here and pulled out one of the control signals just to make sure that if I ran the test it would fail, and it did, and all of that seems to be working okay. And so again, I'm running this really system at a 4 megahertz. That's what's coming over into this. That 4 megahertz, I'm going through the first 64K of this memory, so 32K on one chip, 32K on the other chip, because it's a high and a low. And I'm backing up what's there. I'm writing a new value. I'm reading the value. I'm comparing, and basically then ultimately restoring the value at some point. So I back up to this thing called mem test temp, and then this is where I put back the original. But I work through all that. I'm doing those testing steps, and that seems to be working out fine. So I'm happy with all that. I think I now can proceed with some other work here. And that next steps that I'm going to get into then is to connect up the other set of multiplexers and video memory for my frame 1. So I tested frame 0. I can get to the first segment of 64K within that just fine. That gives me high confidence I can get to the other segments in there just by flipping that register, so that shouldn't be a big deal. Then I've got my frame 1 multiplexers and VRAM. I need to add in another pair of transceivers that goes with frame 1. I need to get my config register working so that I can switch between frame 0 and frame 1. And probably just test the first 64K of frame 1, and then I'll do the rest of the control register so that I can test all 16 segments of both frames, and that'll allow me to do my full 2 meg worth of testing. I'll need some updated logic to go to my PSOC to support that, but then that should get me to a full 2 meg test capability from the 286 through that 64K address window, along with the help of this configuration or control register on the video circuit. So that's where I'm at. I think things seem to be going okay so far, and like I said, if I can get this next set in, get my register working, I then should be able to flip between the 2 frames. I should be able to write to all of the memory, and if that ends up being successful, I'll do a post on that or what I learn along the way there if it's not successful. But then I think I can come in and start doing the output side of this, where I can grab the output and have it read the VGA one frame or the other and send it out through the rest of that circuit. And that'll mean that I have to get this fully connected in with all of its addresses coming in. So next step, just make sure all my RAM's working from the 286 perspective. Step after that is to get all the addressing for the VGA tied in. And then probably the step after that is to actually get VGA output working if I can at 640 by 480 by 1 byte. So progress is being made and more to come.